I'm auditing and fuzzing basically since 2021. I'm also teaching at Czech Technical University, uh, and we are internally developing a tool called Wake, with which we will be working today. And it's different from the current tools mostly in that you are fuzzing with Python language, Solidity code, so you are not using the same language, and it has some advantages over the other tools when you are testing with a different language. Um, yeah, and also I accidentally named the Holešovice, that's not. So, manually guided fuzzing. So what is MGF about? It's about invariants, execution flows, uh, mostly. We will see later what is the fast state machine, but the key point is you probably know what is invariant, right? It's some piece of code that should hold all the time. Let's say you are checking the invariant if total supply is still equal to the total supply in the code or something like that. And flow is something what tells you how to interact with the code. So we are giving flows to the fuzzer, and we are checking invariants with that. So simple flow here. Uh, we have some sender, some recipient, and some amount. First thing, we will mint some ERC20, and then we transfer token. Okay, so Wake framework, it's Python based, it's open source. I hope you will install it and follow me with the demo. And one great thing on it is it has auto-generating typing stubs. That mean that when you are writing your tests, you have like a very rich type hinting. So it helps you to write tests more easily. It also helps LLM to understand what it should autocomplete and something like that. So it's very helpful. It has also forking support, so if you have some, for example, let's say new contract what you are developing and you want to connect it to the rest of the architecture that is already deployed, then you can simply fork the mainnet at specified block or other chain and use locally test with these mainnet contracts over your new developed contract. So it's very handy, and with the newest version of Wake, it's also extremely fast. So you can, for example, fuzz only on fork contracts. So you can, for example, deploy your new protocol that you were testing locally, but you can pass the addresses to your test, and you can like fuzz it on chain. Uh, Okay, and great features are test reproducibility. When you are fuzzing, it always starts with some random seed, and that random seed is displayed to you, so you can reproduce the fuzzing sequence to get back to the same bug what you like encountered during your testing. And also there is a feature for shrinking, so you can easily reintroduce the bug with the saved sequence. And the latest version, if you will do pip install eatwake, it will install version 420, I think, something like that. But if there is also a release candidate, I will show you the command then. And that way you can install the newest version. For today's demo, it will be working with both versions. I will be using the newer one because it has a rewritten core in Rust, so it's very quick and more comfortable to use. So the fast test state machine. Uh, we are basically writing some Python class and filling some sections in it, as you can see on the snippet on the right. So The fastest starting with pre-sequence, where in the pre-sequence you usually want to deploy some contracts or do some initial steps that will help you to better cover, help the fuzzer a lot with next coverage. Then you have flows, and those flows are executed with some weights. We will get back to it later. You can set weights for each flow, how much it should how much times it should execute. There is several other helpers, but the main point of this is that you are executing flows, and after each flow, you execute all the invariants. And this way, you are just going, for example, here you have 10 sequences and 100 flows. That means it will run first sequence and execute pre-sequence, 100 flows, and 200 invariants in that case. And then it will start from the scratch and get to another sequence and again run 100 flows. So this is very important number to balance. Sometimes it's more viable to start from the scratch after some number of flow because it will help you to better cover the possible space where you can find bugs. But sometimes you want to execute a lot of flows in a row. So it's good to play with it, make one number bigger than another, and then switch it, for example, and try how it will behave. Yeah. Best practices are basically that you are creating flow per each transaction. That means that when you will be testing it, then you will execute all transactions randomly based on the weights distribution what you selected. But sometimes you can also create more flows, which will help you to reach some state that won't be usually reachable by a usual fuzzer. Then the important thing that you are trying all the time, optimize the fuzzing by combining stateful and stateless fuzzing. So some things are more viable for you to check with assertions, let's say events and errors, and other things that are based on some state variables and so on. These are better to check with invariants. Yeah. And this one is also important, view functions only used for invariants. So we will be practicing here differential fuzz testing. That means that we will be basically creating model in Python of the Solidity code base, and we will be testing over it. This helps us to discover very neat bugs, and for that, you have to always check against your storage in your model, against your expectation, and not from the view functions from directly from the contract storage. So these view functions are usually used only in invariants, where you are checking if actually the thing what is happening in contract is same as your expectation in your Python model. Yeah. And one very small thing which we will not probably encounter today, but if you will be using set, then I recommend using ordered set because it's otherwise messes a little bit the random seed generation, so you will not have a reproducible fuzz test. You see that there on that slide there is always that QR code, so when someone comes later to this, so he can just join to it. But there is the link to the GitHub what we will be doing together. Okay. So we will go quickly through the structure of the flow. So first thing is decorator for flow, which tells fuzzer that this function is a flow, and then we are preparing some random inputs. So this is a very important part. We can choose some more realistic numbers to help it to not just for example, be generating some numbers that are close to uint max, so we can like change the probability and choose some corner value, something in the middle, something more realistic, so we can play with it. The other part is pre-execution. So that's the thing what you are preparing before you are executing the transaction alone. In this case, it's just that you are minting some token and approving it, but and it's extremely helpful because a lot of fuzzers are actually just waiting when a proof is called, and then they can call the transaction itself. But since you are guiding fuzzer here, that means that you can do it, so you will have a like 100% success rate. And when the transaction is, for example, more complicated, you can, for example, do some signing here, some payload creation, and so on. So this is also an important part. This is like where the auditor or engineer is just thinking about it very deeply to like prepare random inputs that will be given to the fuzzer, but also to try to help to catch all the possible ways of executing the transaction. And there is the execution itself. So we will be also using today a very helpful thing, which is may revert wrapper. And it is helpful in it that the transaction can revert or it doesn't need to. It maybe can sound weird, but it's very useful since you can catch the exception and then you can like enumerate under it all the scenarios and like nicely handle the return values or reverting values from the transaction. Yeah, and this is the part when you are checking errors. Then you are checking events in transaction. And the last thing is that you are updating the Python state. So the invariants will be succeeding or not based on that if there is some bug. Okay, so this is from the presentation. So we can jump to the example. So who will be following today? What? Who? No? If you have working Python environment, then it is like very quick to set it up. Great. Is it somehow readable? Yeah. Okay. So we have there like some simple token vault. We can see that there are defined some errors. There's some immutable value for token. Then some state variables, some events. Then in constructor we are specifying the token and some minimal deposit and maximal deposit amounts. Then there is function for deposit, for withdraw, for emergency withdraw, and some setter and view function. Cool. So if you will check the repository, there are also already solutions, but we will start with this one. Okay. Okay. So there's the template what we will be filling, and so let's start from the first line. So we are importing some basic things that are helpful for Python testing. What is great, since you are working with Python, you can import anything. You can, for example, import some graphical libraries, and you can write unit tests that will also draw something. It can draw some curves or help you understand tokenomics of a token, so you can do anything there. For example, during some audit, I created a fuzzing campaign where in the end I vibe coded dashboard where I just exported all the data from the fuzzing to CSV, and that CSV went to the vibe coded web server, and I could just check on my phone in the kitchen how my fastest is being executed on local network. So you can do like a lot of things with it. It can, it's great that you can like use all the usual stuff from the Python and leverage it on the testing Solidity. Then there is import from Wake and from Wake fuzzing module. Then we have there the important thing, which is PyTypes, and those are that bindings to Solidity that helps us to get type hinting. And then we have their logger because it's more effective and easier to use logger than just printing something in fastest, so we will be using logger. You can place the logger.infos everywhere in your fastest, let's say after each flow execution and so on. And when you run it, then you can observe the logs that there is happening something. But if you want to have a long-running task, then you can just change the level for the logging, and it will be without output. So it's very comfortable, and I recommend using logger for it. Yeah. And there is the class which inherits from fastest. That means that it will have properties of our fuzzer. And there is the pre-sequence function where we'll be doing deployments, flow, and some invariant. Then we are connecting their chain Anvil or Revem or whatever you will be using, and then we run the test in this way, specifying sequences count and flows count. Is everything understandable right now? Great. So the most important thing probably that will help you to save a lot of lines of code is like designing the fast test. So what like state variables you will need, how you will represent them, and so on. So when you have some mapping, you probably want to create some dictionary or some set or something like that. And for these state variables, you will also need to hold the state in Python. So we can start. So we will definitely need some token. That's correct. And yeah, we will need to represent the vault. In this particular case, we probably don't need to use more vaults for testing, but when you have more complex protocol, then you probably want more instances, or if it is cross-chain, you want to also have some more complex variables for representing it on several chains. So in this case, it will be vault inact, then we can have some owner, okay. And this seems this could be everything we need. Cool. So now we will go to the pre-sequence. In pre-sequence, it is important to initialize all the variables that we have defined in the class. And it's again hinting me something, but it seems it could be useful. So I will just replace this with, instead of a random account, I will use their chain.account0, so it will be the first account. Default dictionary for token balances. I don't have this thing. Ah, yeah, I have it. Cool. And we are deploying some mock. This is how the PyTypes file looks like. And we can see it is this file in helpers. Okay. And if we hover over deploy function, we can see the type hinting. So when you are typing deploy, it helps you say what are the constructor parameters. and then we have their minimal deposit amount. So yeah, it can be something like this for this purpose, and the maximal deposit amount must be bigger than the minimal. So to make it sensible, so yeah, we can love it. And there is deployment of the vault. So if we will try to run it, uh, uh, when you enter the project, this already has existing wake configuration file, so you can just call wake up pytypes, and it will create you that Python bindings which will be used for executing in the fuzz test, and then we can call the fuzz test. So we can see it passed for that 100 flows because we are not doing anything, but we can see that the deployment was successful. Great. Tak. I will place breakpoint here, and I will show you probably one of the greatest things on like testing with Python is that you can, during that fuzzing, you can place breakpoints or on several places and use it like for debugging. So now it is in pre-sequence, so it means that the fuzz test will always stop at the beginning of the fuzzing sequence, and if I'll execute it, then I will get like a interactive console where I can interact with the state of during the fuzzing, which is great because you can, for example, create some fuzzing campaign which is running. Let's say you will set it will stop after some time, so you will let it run, let's say 2 hours. Then you will enter it, and you can create there some entropy. You can check the state, or you can call some special functions, and then you will just hit continue, and it will finish. Since we had there just one sequence, so it finished immediately. But if we have 2 sequences, then it entered, and in the second sequence, it stopped here. So when we are in the debugger, we can explore what we have. Like so, what is self.token? We can see that there is this address. We can explore what are the set values, and we can call functions on the vault contract. For some reason, there is sometimes slow in debugger that time hinting, but there you can see everything what you can call on it. So we can call, for example, this thing, and this case we could, for example, create. It will be like totally useful invariant, but we could check that the address what we have in the storage is same as the one which we are accessing with view function. Okay. So this is the breakpoint thing, and now we can start preparing flow. Any questions until now? Okay. So let's start with the deposit function. So we have created vault, so we will just access it in the flow. But we will start with preparing some random input. So we will need to craft some amount, which makes sense to do something like this, but I will get to it later. So let's say we are sending this amount, and we will need what's there? We will need some tokens, right? So we will use a cheat code, mint ERC20, which takes some parameters, and it's the contract ERC20 what we are going to mint. Then who will be the recipient and the amount. So we also need some recipient, which will be the sender, uh, which will be the caller of the deposit function. And I don't want this. And we will need definitely to approve the token. Yeah. Uh, each transaction has a special keyword from underscore, with which you are telling who is initiating the transaction. Okay, so this way we have a pre-execution phase ready, and we can just call the deposit function. So we will go to self.vault, and we will call the deposit function. Here you can also see that nice type hinting, so it's very nice. Deposit and the amount. And we want it from the sender. Okay, we can try to execute it. And we have some bug. So we were showing a breakpoint before that. We can, when we have some bug, it's useful to look at the seed what we had and save it before we will be fixing some other bugs. So we will use the seed with this parameter, and this way we can ensure that we will always encounter the same bug at the same stage of the fuzzing. So that's a good practice. And the other thing is when this thing happens, we can pass -d, which will automatically attach the debugger when it fails. So we can see that we are in this test case, but the important thing, I'm talking about debugger, but it's still like Python debugger. It's not debugger in the Solidity, but it still can help you like a lot of with the state exploration and some bug debugging. So we can see that this function failed, and so we need to like somehow extract error from it, and that's where the may-river handler is useful. So in this case, like we can either let's do something like this. If e that value is not none, breakpoint, and this way if it fails, then the e value contains something, and we can see that there is some exception wrapper. If we will check what is the value, then we can see that we are triggering the below minimal deposit. And if we go further, we can go to the transaction itself, and we can trigger the call trace. So in this case, the call trace is very simple, but I think this is one of the most powerful things for debugging, because when you can easily catch errors, classify them, and also access their call traces, everything programmatically. So it makes the testing like much more powerful. And here we can see that it's this value, and so we will just since we are in debugger, we will check what is our minimal deposit amount. We can see it's this. So we can see the problem is here. So we will need to adjust yeah. And now comes like a very important decision. Do we want to generate the random amount from the where the lower bound will be the minimal deposit amount with which this bug will be mitigated, or we want to like parse the error and check it if the error is triggered. Well, this is like still this is a dilemma what you will be encountering when you are writing fast tests all the time, and I think the best way how to do that is to somehow try to audit this little part and to unit test it and think about it. If you are 100% sure that you will not get any additional value from testing it on a reverting scenario, then it will be better to generate, in this case, the numbers from the minimal deposit amount. If you think that you are not 100% sure and you can benefit from getting the reverting scenario, then it's better to also check for the reverting scenario. Also, what I'm usually doing, that I'm playing with the probability. So I'm usually trying in some scenarios, let's say, revert just 10% and make 90% non-reverting, because if you will not be handling these cases, the fuzzer will be wasting time in reverting scenarios and it won't be interesting. So in this case, we will just generate the random inf between the correct bounds, because the contract is simple and we can verify the out of bounds errors on ourselves pretty confidently. Yeah. So now let's try to run it, and it finished. So we will just clean it a little bit. Yeah. So we can also add some logging here. Let's say this. When we run it, we can see that they are changing some addresses and they are depositing some amounts. Okay. Everything clear? No questions? Okay. So we have kind of some flow that is doing some deposit, and if we will have more flows here, we can, for example, set weight. So initially all the flows have weight set to 100. So if I will have one flow without this argument and one flow will have this, that will mean that this flow will be triggered and that 10% of probability over the other one. So this is also very important, because you usually want to call some critical functions on the contract that will be like mostly used. Those will have a big flow, but you also want to call some setters from admin, which will change some configuration value and so on. But you don't want to change it too frequently, because otherwise you will be in uninteresting branches in your fuzzing. So you can have like, let's say 2000 for some flow, and you will just take 5% probability that there will be something else. So it is also very useful. The other useful thing for flows is that you can define some preconditions where if this lambda function is not correct, or the statement what you have there, then the flow will not be triggered at all. So it will not be reducing the number of flows from the whole campaign. So that's also like a very important thing and very helpful. Yeah. So so we are executing something, And now we can, for example, write some invariant. We are getting just less time. And what could we test? I don't know. For example, total supply. So if something is deposited, so we can track. Yeah, yeah, there is total deposits, right? So we can track the total deposits if they are correctly increasing. So we have already some value for it, right? No, so we will create it. And I think we can also add these ones without this. Yeah. So in the end of the transaction, we are changing the state. We are always using our values from Python. We are not using like view functions from contracts because we always want to like work with our expectations and not with the state. We are just comparing to the state if our expectations are correct. And so we are just taking the amount which is there used, and there we can make assertion if our total deposits are same as the getter from the contract. Yeah, and we have to also initialize it here. Yep, so at this time we have now one flow and invariant which are checking if total deposits are increased. So we can create another flow that is for withdraw. So what we have here, some amount, random ins. So we will be withdrawing some random amount from 0 to the amount that the user actually has. And we will call the withdraw and see what will happen. So here we can see that we are passing 0 amount and it's not allowed. So we will just increase it for 1. Like I think most of the bugs with fuzzing I was discovering just by writing the fuzz test. Since you are rewriting the solidity logic into that Python model, you will just verify a lot more things than you will verify just with a manual review. You are just checking, like, you are trying to hit like the 100% coverage. So you are trying to execute each piece of code with this fuzzing campaign. So we are checking for everything, and thanks to that, you will just encounter some bad scenario just by writing it and not just by running it for a long time. Yeah. Okay. So we can see we have there another issue. And that's because we are passing bad values here. So we have to have also some check where if we pick some random account that doesn't have any funds, so we will not be failing on this random integer generation. So if self, we want something like this. So this might work. Yeah. And now we can see that we hit some assertion error, and if we check it with debugger, we can see that we failed on our invariant for total deposits. So that's because we are not like updating the state for the total deposits. Once we will do it, we'll be good. Okay. So everyone after today should know what is flow and what is invariant. Does we accomplish that? Yeah? Cool. So there is much more things what we could do and what I could show you, but we are just losing time. One of the things is, for example, that if we would like to fork, we don't need to deploy their mock token, but we can, for example, just use interface of it because it has transfer min functions and so on. So we will just use it as interface, and we will pass there some real address, which is, for example, let's say USDC. And when we have some others there, it means we will need to fork the mainnet because on the address there is not nothing yet. So we can just connect to some RPC, let's say from public node, and if I have connection, then we can see that it's connecting to the RPC node, so it is a little bit slower than when it will establish the connection, and you can see it's much slower because there is very shitty connection. Sorry, but this is how it slows your fastest if you have a bad connection and you are forking. But now what we are doing is that instead of some mock, we are just actually testing this contract with the real USDC, and that's great because when you have such code base, you can then, for example, create some list which will contain weird ERC tokens, let's say USDT or others, and you can test the code base with, by changing all these tokens, and if it breaks somewhere. Like it was very common that I've written some test cases, and then I just replaced this address for USDT, and it seemed that it was like immediately obvious that the code base does not support that, even though that they were planning it. So this is a very, very useful thing. Okay. And what we could do more? Is there something what you would like to know? Like we can proceed with like enhancing more this fastest, or I can show, for example, some solution on a problem what you will have. Well, we can, for example, check the solution and look what's there. So nice thing what we were mentioning is checking events. It's like it doesn't seem much important from the first place, but it can save a lot of things. So we can like access the transaction events, and then we are checking the events if they are triggered and with correct values. So it can be seen here. And there it is for the other flow, and yeah, Uh, as I said, you usually want to create flow per each function. So the next steps will be to create emergency withdrawal flow. The other will be setter for these deposit limits. And the other thing will be that we can perform just some transfer which could like increase the entropy and create such invariants. Okay, so if there are not any questions, so I think that's it, and I hope I somehow showed you how you can like fast test in Python and what are the like main benefits of it. Thank you.